friends, welcome to the channel Physics by IITians, where we learn physics to crack examinations and understand physics to crack interviews. If you are thinking to subscribe the channel, please subscribe it and don't forget to press the bell icon for instant updates. Today we shall discuss some very basic topics or very basic concepts of electromagnetic theory by discussing some important questions. So let's start our video. The first question is, for a plane electromagnetic wave that is given by Ez equals to A cos omega t cos omega ct and Hy equals to minus A sin omega x sin omega ct. So the question is, the instantaneous value of the Poynting vector will be, you are given the four options. So Ez is A cos omega t cos omega ct and Hy is minus A sin omega x omega sin omega ct. So instantaneous Poynting vector is S equals to E cross H. So E is Ez here and H is Hy here. So put the values of Ez and Hy, that is A cos omega x omega cos omega ct and minus A sin omega x sin omega ct, and also the direction is, this is along Z, this is along Y. So Z cross Y or K cross J, that is minus I cap. So direction is minus I cap. So after simplification you just multiply. Okay, so multiplication and simplification, we get that the value of the Poynting vector is A square by 4 sin 2 omega x into sin 2 omega ct. I have just simply multiplied the whole things and did some simple simplifications. Okay, so this is the option, that option B is correct. This 1 by 4 A square sin 2 omega x into sin 2 omega t. What you have to remember here, the formula. If it is not Hy, if it is given in terms of B, then you have to write it 1 by mu into E cross B. So mu will be mu naught for free space, or if it is not mentioned in the question, otherwise it is 1 by mu. Okay, or so let's come to the next question. The next question is, a monochromatic electromagnetic waves means that the field strength at a point varies with time according to sine or cosine function. The wave always travels in the same direction. Electric field vector E lies in one direction only. Magnetic field vector B must be perpendicular to the direction of propagation. Now monochromatic electromagnetic waves, that is, suppose this is a monochromatic wave. Monochromatic means the wave that is having only a single frequency, that is only a single omega or a single lambda, and this can be expressed as, suppose this is our monochromatic wave, the wave is propagating along z direction, and we can write it, the electric field for these components can write it for the electromagnetic wave E naught cos omega t minus kz, or electric field in terms of the general expression, electric field will be from RT. The R can be along x, along y, along z, or can be combinations of x plus y, combinations of y plus z, depending on the direction of the propagations. Okay, so this is the most simple expression. So this is the expression for the monochromatic wave. So the field strength here, look at the picture, the field strength is varying sinusoidally or exponentially varying function. So the field strength, it is cosine or sine, we can write it in general, or in generally we can write, express it as an exponential function. So the answer should be, the field strength at a point varies with time according to sine or cosine function. Okay, now I want to add something, that is, what is the difference between monochromatic and polychromatic wave. Look here, they are coherent also, the monochromatic and coherent light. So coherent means they have constant phase difference between the four waves, and the phase difference here is absolutely zero. Okay, but here look, this is polychromatic light. There are different multiple frequencies, one for blue, another for green, another for yellow, another for red. So this is a polychromatic light. Now look here, the sources which are giving us monochromatic or polychromatic waves. So this is sunlight. Sunlight is giving us the multiple frequency or non-coherent polychromatic light. This is the incandescent bulb, so single frequency, but it has non-coherent, like sodium lamp. If sodium lamp is glowing, it will glow of the light will be yellow in color. So it is apparently single frequency, although from quantum mechanics we can tell that there the exactly monochromatic light lambda or omega or nu, whichever you want to tell it, it cannot be possible because of the Heisenberg uncertainty principle, because in the energy levels also there are also uncertainty in the energy level, that is delta E into delta T is greater than equals to H cross. So energy levels, the transitions is not defined from a proper energy levels. So the transitions is not defined from a single energy level. How can you expect that this E, which this delta E, which is arising, which is giving us the light, or delta E equals to hc by lambda, if this is uncertain, so lambda must be uncertain. So there will be some inherent uncertainty. So exactly monochromatic light we cannot get, but if we think that this is a single some lambda with having a very small delta lambda, small amount, or nu with a very small delta nu, amount of delta nu, that is frequency. So very small amount of fluctuation or wavelength with a very small amount of fluctuation in the wavelength, then we can think it as a single frequency light. But this is in non-coherent, because look here, there are no coherence between these lights, between the several this individual wavelengths or individual phases of the wave. Now look at the laser light, see the difference, how much it is coherent. So this is each and every point here, they are uh, they are exactly correlated, the phase are correlated with each other, and this is the single frequency coherent light. Okay, so sunlight, incandescent bulb, laser light, the different light sources can be think of like this way. So come to the next question. Let me see if there is any question in between. No, there is no question in between. So come to the next question. An electron is describing a circular orbit of radius a in a plane perpendicular to the z-axis, along which there is a uniform magnetic field B naught, the magnitude of the angular momentum. So electron is moving along a circular orbit and it is acted by a magnetic field B naught, and you are asked to give the angular momentum L value. Okay, so the electron is in circular orbit, so m v naught square by a equals to q into v naught, where v naught it is velocity. Now v naught should be q v naught by m into a. So p will be, momentum will be m into v naught, so put the value m into v naught as q m into q b naught a by m, that is we get, and we got earlier, and then find out the angular momentum L equals to r cross p, that is L here a and p is q b naught a, that is b naught into q into a square, or here in questions q is denoted as e, electronic charge, so b naught into e into a square. So option C is our correct option. Okay, you have to think it. For the circular orbit motion of the electron, the centripetal force that is due to this mv square by a, that is the, and it will equalize by the force that is acted on the charge, which is due to the magnetic field. That's why these two forces are equal. mv naught square by a equals to q v naught b naught. Now next question, consider the reflection and refraction of a plane wave at a dielectric interface. Which of the following is true? The frequency of the wave does not change, the energy of the wave does not change, polarization does not change, or momentum does not change. Always remember that upon the reflection or refraction of a plane wave at the dielectric interface, I have also download a picture here. Look at here, this is a reflection phenomena and this is a transmission phenomena or refraction phenomena. Suppose this is a dielectric boundary. So upon whenever this is happening, the frequency of the wave is always constant. Okay, so there will be no change of frequency, or the frequency of the wave does not change. Next question, the power radiated by an electric dipole is proportional to the frequency by omega, omega square, omega cube and omega to the power 4. I have discussed in detail where the power of the oscillating dipole or radiation by the oscillating dipole. Please watch that video. You will get your concept clear. I have discussed the formula here. The Poynting vector is proportional to omega to the power 4 and the total power can be get the average with the Poynting vector as integration of s dot dA or integration of s dot ds. So that should be proportional to omega to the power 4. So the power radiated by the dipole is proportional to omega to the power 4, oscillating dipole. Okay. So the option is D. That is the correct option. The next question is the dispersion relation of a certain wave omega equals to root over c square k square plus root over m plus m square, where omega is the angular frequency and k is the wave vector, c is the velocity of light, m is the constant. Now the group velocity v or vg of the wave has the following properties. V tends to c as k tends to 0, v tends to c as k tends to infinite, and there are given different 3 other options. So let us check it out first what should be the answer. So we are given the dispersion relation omega as root over c square k square plus m square. Now omega square equals to c square k square plus m square. You just direct square it. Then differentiate it. 2 omega d omega dk equals to 2 c square k. Now d omega dk equals to c square k divided by omega equals to, now put the value of omega as c square k divided by root over c square k square plus m square. Okay. Now this d omega by dk is vg, या group velocity or v here, that is c square divided by, arrange it, that k you divide this whole k, this k square, so the k will be cancelled and this will be c square plus m square by c square, m square by k square. Okay. Now we get vg equals to c square divided by root over c square plus m square by k square. When k equals to 0, this becomes 0, so this term will be infinite and this term is infinite in the denominator. So vg will be or v will be 0, and when k is infinite, so k is infinite, so this term will be m square by k square will be 0 and this term only left with c square divided by c. So the vg equals to or v equals to c. So option D is the correct option. As v tends to 0, k tends to 0, as v tends to c, as k tends to infinite. The next question is, given the field electric field, that is k by r into ar cap in cylindrical coordinates, then the work needed to move a point charge q from any radial direction r to a point at twice that the radial direction, the distance, that is 2r. Okay. So you are given that there is an electric field, you have a certain charge q and you want to move it from r to some you have to do for moving the charges. So the electric field is given as k by r into air cap. Now work need to move the charge from r1 to 2r1, suppose the values. So field has only radial component. So dw will be, that is minus f dot dl. So that is minus qe dot dl or minus q into er into dr, because only the radial components here. So er is given as q by k by r. So k by r into dr. Now integrate it from r1 to 2r1. So minus kq will be outside here as constant, and this is our integration term, integration over r1 to 2r1 dr by r. So after simplifying we get w equals to minus kq ln2. So we have to do the work done minus kq ln2. Okay. Now the next question will be, when a monoatomic gas atom is placed in a uniform electric field E, the displacement of the nucleus is proportional to E square, E cube and independent of E. So I have discussed it in this dielectric constant in video. What is happening whenever the atoms or molecules are inside a external electric field, inside an external electric field. Please watch that video. Also I have given some concepts here, that whenever you are applying an electric field, there will be creation of induced dipole. So induced dipole means the center of positive charge and the center of negative charge will get displaced, and for that displacement we get certain dipoles, and this is not a permanent dipole. Although if the atoms or molecules are polar, then we can have intrinsic dipole moment, but in generally we don't consider it here. So this is not a permanent dipole, rather it is an induced dipole, and this is where there will be polarization, and that polarization will be due to the applied electric field. So this polarization is directly proportional to the electric field, and the polarization, that is displacement here, that is of the nucleus or of the electron, it is due to the displacement, the electric field E. Okay, it is not due to E square, not due to E cube, or it is not, it cannot be independent of E. So an atom is said to be polarized when its electron cloud has been shifted with an influence of an external charge, or external field. The electron cloud is not centered on the nucleus. So we get the polarization of atoms, and this is directly proportional to the electric field vector E. Okay. So here option B is the correct option. Now come to the next question. 3 point charges Q, Q and 2 minus 2Q are located at 0 minus A, 0 AA, 0 0 minus A respectively. The net dipole moment of this charge distribution is how much? Now the dipole moment is defined as, if there are positive charge amount of plus Q and negative charge amount of minus Q, they are separated within a small distance of R. So dipole moment P equals to Q into R. So here we will exactly do the same thing. We are given several charges and we are given the locations. So locations we can write it in terms of x, y, z coordinates, that is I cap, j cap, k cap. First one is 0 minus a, that is x1 equals to 0 I cap minus a j cap plus a k cap. x2 should be 0 I cap plus a j cap plus a k cap. x3 should be 0 I cap 0 j cap minus a k cap. So net dipole moment should be q into x1 plus q into x2 minus 2q into x3. So you put the values of x1, x2, x3 and you get it as the total dipole, net dipole moment as 4qa into k cap. So the answer will be 4qa into k cap. So look how much simple it is. It is like that, it is a very difficult question, but it is not like that. It is a very simple question. You just find out the coordinates and write it in terms of I cap, j cap, k cap, and then over some to get the net dipole moment. Okay. So come to the next question. There be a homogeneous isotropic dielectric with a plane surface, and in a region external to it there is a uniform electric field E making an angle theta with normal to the plane surface. The dielectric constant of the dielectrics is K. The direction of the electric field E prime within the dielectric. So suppose there is a boundary here. You have to understand this is a dielectric boundary, and this is different. Okay, they both are different medium, and here this is a boundary in between here, the two mediums. Now this is the parallel to the boundary component, and this is the perpendicular to the boundary component. Don't confuse it. Okay, don't confuse by the diagram that what is the parallel and what is the perpendicular. The parallel component is parallel to the boundary and perpendicular component is perpendicular to the boundary. So here it is the electric field, suppose E prime. So you make composed of two components. It is composed of two components, or it can be split into two components. If some it is electric field, it can be, it is making an angle theta. Then E is, this is E cos theta, this is E sin theta. So split the components and get the value. It is as E prime sin theta prime, and this will be as E prime cos theta prime. Okay, and also do the same for this electric field E, that is here it is E cos theta, and along this direction it is E sin theta. So the parallel direction you are getting sin theta component, and perpendicular direction you are getting cos theta component. So here, so now applying boundary conditions we get that epsilon 1 cos theta into E equals to epsilon 2 cos theta prime E prime, because this is a dielectric interface, so sigma will be 0. And the parallel components for the electric field is E sin theta equals to E prime sin theta prime. So divide these two equations, we get E sin theta by E1 cos epsilon 1 E cos theta equals to E prime sin theta prime by epsilon 2 E2 prime E prime cos theta prime. Here epsilon 1, epsilon 2 are taken to be the dielectric constants of the two mediums. Okay, and then after simplifying you get tan theta by epsilon 1 equals to tan theta prime by epsilon 2, or you can write it as, this is a mistake, okay, don't look at this, tan theta prime by tan theta equals to epsilon 2 by epsilon 1 equals to k. K is given, okay, k is the dielectric constant of the medium. So the answer is tan theta prime by tan theta equals to k. So option A is the correct answer. Okay, so you have to remember, or don't remember, you have to understand it, that whenever there are a boundary conditions problem, you have to find out the parallel component of the boundary and perpendicular component of the boundary, and then apply the boundary conditions, that is d perpendicular, d1 perpendicular minus d2 perpendicular will be sigma, and E2 E1 parallel equals to E2 parallel. Now if it in case of dielectric medium, sigma is 0. Okay, so d1 perpendicular should be equals to d2 perpendicular in case of dielectric medium. So friends, the discussion is enough for today, I think. If you like the video, please share with your friends, and also don't forget to like this video, and also put your valuable comments. Your good comments also inspire us. Thank you.